Use the graph f of x equals 2 to the x to obtain g of x, which is 3 times 2 of x. Anytime you multiply the original parent graph times a number on the front greater than 1, this is a stretch. So let's find ordered pairs of the original graph. So I have 0, 2 to the 0, plugging into the original graph. 2 to the 0 is 1. Plugging in 2. 2 to the first is 2. Plugging in 2. 2 squared is 4. Plugging in negative 1. 2 to the negative 1. 2 to the negative 1 would be 1 over 2, which is a half. Plugging in negative 2. 2 to the negative 2 would be 1 over 2 squared, which is 1/4. 2 squared being a fourth. Plugging in negative 3, that'd be 2 to the negative 3. So that is 1 over 2 cubed, which is 1 over 2 times 2 is 4. 4 times 2 is 8. So let's graph the original graph, the parent graph. So 0, 1, 1, 2, over 2 up 4. Actually, I could have gone ahead and used 3. 2 to the third would be 8. So I could go over 1, 2, 3 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. You can plug in as many numbers as you want, actually. But I'm just trying to pick a few positives, pick a few negatives for us to get the idea of what the graph looks like. So plugging in negative 1, I'm at a half. Negative 2, I'm at a fourth. Negative 3, I'm at an eighth. So here is that graph that we've been looking at and using as our parent graph. So this is f of x equals 2 to the x. Now let's talk about how we get the ordered pairs of a stretch and a shrink. Okay? Now, let's use these same ordered pairs. All right, I'm going to use the same x's, 0, 1, 2, negative 1, negative 2, negative 3. Okay? Those are the same ordered pairs that I used here. Now, to get the ordered pairs of your graph, of your stretch, 3 times 2 to the x. Remember in the last video, I said you will take all of your y values and multiply them times your scale factor, which is the number multiplied times the original parent graph. That number will always be in the front, okay? So we need to multiply each one of these y's by 3. Okay, what is 1 times 3? 3. What's 2 times 3? 6. 4 times 3? 12. 1/2 times 3? 3 halves. 1/4 times 3, just multiplying straight across, would be 3/4. 1/8 times 3 would be 3/8. Okay? I'm kind of draw some lines there so we won't get off there. Let me just circle them here. Okay, so that's at negative 1, that's 3 halves. At negative 2, that's 3/4. At negative 3, that's 3/8. Okay, so negative 1, 3 halves. Negative 2, 3/4. And negative 3, 3/8. Okay, so let's graph these. All right, 0, 3, up, 1, 2, 3. 1, 6, over 1, up, 1, 2, 3, 4, 5, 6. Okay, 2, 12 is going to be way up here. Okay, so over 2, up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Somewhere about right there. Negative 1, 3 halves. Punch that in your calculator. That's going to be about 1.5. 3 halves would be 1.5. So at negative 1, I'm up at 1.5. So somewhere about right there. Negative 2, that's negative 2. I'm at 3/4. So negative 2, 3/4 is somewhere about right there. Okay? Negative 3, 3/8. I'm somewhere about right here. Okay? All right, so here is my graph of the stretched graph. So this is g of x equals to 3 times 2 to the x. So, to find a stretch and a shrink, you will always keep the same x's that you had in the original problem. And you will take all the y's that you found, and you will multiply each one of them individually by your scale factor 3. 3 times 1 gave me 3. 3 times 2 gave me 6. 3 times 4 gave me 12. 3 times a half was 3 halves, or 1.5. 3 times a fourth was 3/4. And 3 times an eighth was 3/8. So that's how you'll always find your ordered pairs of your shrink or your stretch, by multiplying the original y's by the number that was added in the front that formed your stretch or your shrink. Excuse me. If it's greater than 1, if your scale factor is greater than 1, it's a stretch. If it's a fraction, it's a shrink.